Hey class, so today we're talking about 6.5 objective 1. And the first problem we're going to work through is theta is equal to 37 pi over 6. And what we're looking for is the reference angle theta r. So this question on MyMathLab is going to be broken up into a couple different parts. The first part is going to be to find this angle's least non-negative coterminal angle. So as we've talked about many times in this course, theta c, its formula is simply 37 pi, or your original theta, minus 2 pi times our unknown integer k. Technically, this should be a plus because k can be positive or negative, and in this case it'll be negative. So just as a reminder, remember that the range for theta c is 0 to 2 pi. So since this should be just strictly a less than, so since our original angle, 37 pi over 6, is greater than 2 pi, that means that our k is going to have to be a negative integer. So how can we figure out what this k is? Well, we can approximate this by taking the ratio of 37 pi over 6 divided by 2 pi. So remember, 2 pi is a full rotation, so by taking this ratio, we can see how many times it's gone a full rotation. And this number of rotations can be rounded to be our k. So an easy analogy for this is, imagine you have 24 inches. Well, how many times does that make a feet or a foot? Well, to find that out, you can divide 24 by 12, and you'll see that 24 inches is 2 feet. So let's plug this into our calculator and figure out what it is. So out of my calculator, I get a number 3.0833, and that is repeating. If you're not getting this as your answer, remember again to put a parentheses around the 2 pi, so parentheses 2 pi parentheses, when you're dividing. Otherwise, your calculator will divide by 2 and multiply that answer by pi. So now that we have this answer, we know that our k is going to be it's going to be -3. So let's plug that in and see what that is. So first, we want to put 2 pi in terms of this fraction, 6. So that is going to be 12 pi over 6 times k. And then we're going to plug in -3. So this is going to be 37 pi over 6 plus 12 pi over 6 times the -3. And here I hope you can see that 12 times -3 is going to be -36. 37 minus 36 is going to be 1. So we're going to have a pi over 6. Again, that's simply because this is -36 pi over 6. And we have on the left-hand side 37 pi over 6. So we're just adding these like we add fractions and subtract their numerators. Now that we have our coterminal angle, we can talk about the rest of the problem. Okay, so the next part of the question on MyMathLab is going to ask, what quadrant is this least non-negative coterminal angle in? So what quadrant is the angle pi over 6 in? And I hope that you see this is in the first quadrant because it is greater than 0 but less than pi over 2. So this is going to be in the first quadrant. This being the answer to the second question, or second part of the question. Now we move on to the third, which is the main question. What is theta equal 37 pi over 6? What is that angle's reference angle? So you might ask, what is a reference angle? A reference angle is going to be the angle, or I should say, the acute angle relative to the x-axis nearest the terminal side of our angle. So, in the first quadrant, your theta r is going to look something like this. In the second quadrant, your reference angle is going to look something like this, and so on. Third quadrant, something like that, and fourth quadrant, something like that. And I hope this pattern looks familiar to you, because this is exactly how we form our families of angles. So remember that in each family of angle, for example, the pi over 3 family, each member of the family is pi over 3 away from either the positive or negative axis in one of each quadrant, right? So let me erase that, because that is not meant to say pi over 3 for that reference angle. In this specific example, since our coterminal angle is pi over 6, what that means is that our reference angle right here is going to be simply equal to pi over 6. This is because, once again, let me emphasize this is in quadrant 1. So if the least non-negative coterminal angle of our original theta is in quadrant 1, then the reference angle will just be that coterminal angle. In this problem, it happens to be pi over 6. So let's move on to another example. One quick note is that I had written 6.5 objective 1. That is not true. This is 6.5 objective 5, the material that's going to be on your homework due Friday. So here we have another angle, except this angle is both negative and in degrees. So how do we deal with this? Well, we're going to take a similar approach in that the first part of this problem is going to be to find our least non-negative coterminal angle. And remember that this formula is exactly the same as our radian formula, except we have 360 degrees instead of 2 pi. So now we want to approximate this k. Again, the way we do that is we're going to take the ratio or proportion of negative 495 to 360 degrees. Okay, when we put this in our calculator, we get negative 1.375. Now, this is a key difference from our last problem. In our last problem, we had a positive 3.08, so I said k is going to equal positive 3. In this example, we have a negative 1.375, so instead our k is going to be 2. You might ask why that is. Well, the reason is because remember that our coterminal angle needs to be between the range 0 to 2 pi, or in degrees, 0 and 360. Since this angle is negative, when we do the ratio, this is telling us it went around negative 1 1/3 times, roughly. So in order to get this angle positive, we have to rotate it around twice to compensate for that negative rotation. Let me emphasize that again, because we had a little bit of noise in the background. Because this is a negative angle, it goes around the clockwise way, right? But in order to get between 0 and 360, we have to have some amount in the counterclockwise way. If, for example, we only rotated this angle back one time in the clockwise way, or counterclockwise way, sorry, it would still have some rotation going in the negative direction in that clockwise way. So we have to overturn it in order to make it a counterclockwise positive angle. So when we have a negative angle and we do the proportion, we have to make sure to round up k. Okay, now let's see this in practice. Putting k into this equation, we get negative 495 degrees plus 360 degrees times 2. So this is going to equal negative 495 plus 720, which is equal to 225. And now we have our coterminal angle, theta C. Theta C. Let's move on to the second part. Okay, so the next part of this question is going to be asking what quadrant it's in. So I'm drawing our XY plane. And remember that we have a 0-degree rotation on the positive X, a 90-degree rotation on the positive Y, 180 on the negative X, and 270 on the negative Y. Looking at these boundary angles, we can see that 225 is greater than our negative X right here, but less than our negative Y right here. So it'll be somewhere over here. And this, in fact, is the third quadrant. Okay. Now, to remind you from the last problem, remember that reference angles are going to be the acute angles formed by the terminal side of an angle in the nearest x-axis. In this case, that angle is going to be right here. This is our theta r. So, let me emphasize, this will always be the case for quadrant 3. It will always be connected to the negative x-axis in this region. It will have a different measure if we have a different angle, but it'll always look something like that. Okay, now how do we find what this angle is? Well, I've written what the angle measurement is to get from the positive x to the negative x-axis, right? That's going to be 180 degrees. So we need to know what rotation it's going to take to go from the negative x to our terminal side of our angle right here. And the way we solve for that for any given angle in quadrant 3 is by taking theta and subtracting it from, or maybe I should say theta c to be more specific, theta c, and subtracting it from 180, or by 180. So our reference angle, theta r, is going to be equal to theta c minus 180. Let me re-emphasize this again. This is not a reference angle for every quadrant. This is only for quadrant 3 that you use this formula for reference angles. So when we plug our coterminal angle into this formula, we get that this is 225 degrees minus 180 degrees. So theta r is equal to, I think it's 45. And that is our reference angle. I'm going to briefly go over the formulas for each reference angle, and then that will be it for this video. So let me just draw the XY axis really quickly and emphasize again that each of these reference angles is going to be in relation to the x-axis nearest our terminal side. So these are going to be our reference angles. Sorry if this wasn't clear enough. Okay, so looking at quadrant 1, we see that our reference angle is just simply going to be our coterminal angle. In quadrant 2, our reference angle is going to be pi, or 180, minus our theta. So theta r is going to be equal to pi minus theta c. In quadrant 3, our angle is going to be pi plus theta c. Or, I'm sorry, our theta r is going to be theta minus pi. Sorry about that. Theta r is going to be equal to our non-negative coterminal angle minus pi. And then in quadrant 4, we're going to have our theta c, 2 pi minus theta c, because that's what's left of our rotation for 2 pi. So theta r is equal to 2 pi minus theta c. All of this information is included in the e-text in the chapter section 6.5, objective 5, and this should cover all of the material that's needed in order to do the first half of your homework. You have until Friday to get this homework done, and next remote day, you'll be dealing with the second half of this homework, objective 6.